So thank you all for coming today. It's a great pleasure. We are here to demonstrate or introduce our new tool for holistic stormwater management, LID application tool we developed in the Greenskins lab. My name is Daniel Röhr, and I'm very thankful that the city is giving us the opportunity to introduce this tool, because we believe, because of the new policy which they're currently developing for stormwater management, particularly for green roofs, it will be a really useful tool to use. I would like to say that most of the talking my colleague Jericho Baxton will do, but I will just briefly talk 2 minutes about what we do in the lab, and mostly it has to do with being on anything to do with green roofs, particularly with the focus to stormwater management. And the specific idea behind this application is that it is for designers. It is not for engineers. It is actually at the beginning of a project, an application to be used to dimension the stormwater runoff and all the implications that has in urban development. So it's actually a tool for planners, architects, landscape architects, and particularly for the city. It was geared, though it is usable by professionals, and the idea behind it is that it's usable also with the biggest problem with most of these application tools which exist is that the data is complicated to obtain. And this tool is quite simple, and it uses the data of the local airports, and with that it will always be up to date, up to speed with the current climate, because the pilot always needs the most up-to-date data, and therefore it is also specifically useful in the third world where even less data is available for stormwater management. The other thing is this tool is new. We have not yet published it, and the idea behind this is that we will get it published in a peer-reviewed journal, but we are here to show it to the city because we feel it is a very timely tool for the city with all the development permitting happening, particularly in the design phase. It would be a really useful tool to use holistically for stormwater management. And with no further ado, I will ask Jericho to introduce the tool, and if there's any questions after, I have it. So please, Jericho. Yeah, let's
So Daniel gave a really good introduction, but I'd like to lay some groundwork on why we think that this is important and why we think this is important right now. As many people know, climate change is a thing. Our cities are growing quite rapidly. So the urban population is increasing while rural population is decreasing. And what we're seeing is that as this happens, the surface temperatures of the earth are changing. So climate change is very much a real thing. About 97% of scientists throughout the world agree that climate change is a real thing that needs to be dealt with currently. And because of the climate change, we're seeing that precipitation events in urban and rural areas are more and more anomalies are starting to happen. And so what we're seeing is extreme, intense precipitation events that we haven't been able to predict or analyze prior to. And this is happening in a more rapid manner. So every year they get slightly worse. The events could be very short, but the intensity of them are something that stormwater management systems can't currently handle. So what that's doing is it's causing significant flooding conditions internationally. So up on the top left, China, on the top right, Mumbai, which I was fortunate to visit just this last February. They deal with monsoon flooding conditions every summer. On the bottom left, you see Manhattan, so international, right? And then recently, Daniel and I returned from Beijing, where they also flood quite regularly during the monsoon season. But it's not just limited to those particular places. We've seen it even here in Vancouver. So this picture is taken actually just down a block. And I believe it was right outside the Stormwater Management Engineering office. And so they couldn't believe when that had actually happened. And so population growth is leading to increased urban space, right? And then that's increasing impervious surfaces in these rural, used to be rural areas that are now quite urban. And then we're seeing this increased stormwater runoff because we don't have the infrastructure to manage it or slow it down or reduce it. And so major floods, just as you'd expect with the precipitation, is going up quite drastically. So it's not just causing flooding conditions, but it's causing a higher insurance claims throughout the world, and it's causing a lot of infrastructural damage that obviously puts a burden on cities, on developers and contractors. And so these are issues that we are looking at as not just the precipitation itself in these urban environments, but how it's affecting the entire system. So the big question that we are looking at Greenskins Lab is what can we as designers and the municipality do, and clientele and the public, right? What do we need to do to achieve something that might be better currently or in the future? And so what we're looking at is supportive stormwater measures, and in this case, an application that we've begun to design trying to address some of these issues. So traditionally, urban planning process is you build the building and then you design for the infrastructure to some degree afterwards. So like Daniel had mentioned, a lot of these processes for landscape architecture is happening after the initial design development process for the building or the urban space. And so what we need to do is we need to reverse the urban development process, similar to how we are laying the foundation for stormwater management systems prior to the construction of a project. We need to think about that holistically with not just the physical infrastructure of piping and such, but the actual landscape and ecology that can go into play in one particular area or throughout the region of an urban environment like Vancouver metro system. And so what you see on the top is sort of a left to right process. So planning for water as a part of the system initially, and how to move that water throughout the landscape in urban environments, and then developing the buildings around that. So you have a firm understanding of what types of water are going to be impacting your site long before you've actually begun development. So the solutions are quite wide in terms of LID or green infrastructure. They have a number of different impacts on environment and urban environments, but the LID tools that we are particularly interested in Greenskins is the living roof, rainwater harvesting and storage, and then different LID techniques that go along with those are evapotranspiration and infiltration. So green roofs have a high evapotranspiration even in a Vancouver climate. And so part of what you'll see in the application that we've begun developing is how holistically from the roof, from the moment the precipitation, whether it's rain, snow, mist hits the roof, how it moves through the system and then its final point either being the stormwater management system going to a lake or river, or ideally mitigating 100% of this water prior to it reaching that system. So as I mentioned, our focus is on green roofs at the Greenskins Lab, and we are particularly interested in extensive green roofs. So intensive also has wonderful benefits, but they are often used more for public interface or public accessibility, whereas extensive green roofs we see as more universally applicable. So building infrastructure doesn't have to be quite as significant for an extensive green roof to be applied. And in some cases, extensive green roofs can be applied to pre-existing buildings as a sort of remodel for stormwater management solutions. Extensive green roofs come in a variety of shapes and forms. So the one you see on the top left was actually an existing building in China where a researcher just decided to put some soil down, and what was left in the soil ended up growing vegetation, and he left it. And they found pretty significant stormwater management in just the reduction of how quickly it was reaching the street, and then some minor evapotranspiration benefits from that. So very simple things such as just putting soil down can have a huge impact on urban environments. And then there are a variety of other types of roofs that can both be publicly accessible or non-accessible with what we refer to as sedums primarily for the vegetation, as they can deal with many different types of climates. So whether it's quite wet or dry, we find that they are durable in many circumstances. So the strategy for the LID design is what's really most important and what we are trying to address with the application. So there's often a lack of understanding when you are moving into the design process of what's necessary for stormwater management, and that's sometimes happening very far down the actual design process. And what we'd like to do is begin to address that at the conceptual, so that landscape architects and stormwater management can be a part of the building infrastructure at the beginning. And so we need to have an understanding of a goal or a target we'd like to achieve, whether that's something that's city mandated or something that the client is interested in. What are the impervious surfaces? We need to take into consideration our site, but the surrounding environment can also have a huge impact given the location and the topography of the site that you're working on. And then, are there contaminants? How can we implement this LID? Is a green roof the best strategy, or do we need to focus on things that are happening at the ground level? What are the technologies? What do those require? How can they have a significant impact in other manners on the building? And then, does it meet the goals? Will it be sustainable? And then the final point is, how can this material be presented to the client or the public or municipality in which that there's a very clear understanding? I think often with these applications in the building permitting process, we design for numbers, right? And so we're offering numbers to the city to say we've met a requirement, but there's very little understanding for the general public on how those numbers meet or work on the site. And so we are really interested in how we can create that connection to the public so that there's a visual understanding. So what you see on the screen is what we've developed so far. This is sort of working version 3.0. And we are referring to it as the holistic stormwater runoff management application. We are, like I mentioned, we are looking from the roof down to the ground. So we want to consider from the moment this water hits the site in any capacity to the moment that it's leaving us at the sort of final number. So the way that this breaks down is we are trying to implement, we'd like to implement more LID technologies in the future, but for the moment we are looking at green roof evapotranspiration and then the curb number runoff. So things that have already been established through TR55, the curb number runoff method, and then the Han-Sangri method, which is looking at the evapotranspiration rate based off of climate conditions. So what we've done is we've designed something that we feel is more user-friendly and has a visual impact to it, so that upon your initial plugging in of information, you receive the benefit of getting an estimated outcome, but you're also presented with information in a much more digestible manner, so to speak. So the bar graph shows you the precipitation over the year. It shows you the roof evapotranspiration from both an extensive or intensive, if that's a route that you're interested in going. We then go to the roof runoff. So after the water has been evapotranspirated from the roof and slowed down, how much is that runoff and where is it going on the site? And then we've implemented right now a generic LID that allows you to put in what the runoff of that surface is and how big the area is, so that you can then begin to reverse sort of design for the conditions that are presented rather than trying to design for a particular number, right? So if you know that you'd like to achieve 50%, what this will do is it will tell you how much water is initially hitting the site and then how big, you can start to plug in how big of an area you have available and work backwards from that rather than trying to work forwards, which I think is a lot of what the planning process is currently doing. And then as another caveat, we recognize that a lot of these systems will require irrigation. So if a client is interested in having a green roof, green all year round, we put in a roof irrigation estimator so that that's sort of a part of the package. So that there's a sort of user friendliness involved with the process. And then the other large component is we're looking at 2 and 10 year required infiltration for rain events. And so this is based off of the total LID area of the site. And what we've input currently is the Vancouver estimates for what those numbers are. And then what it tells you is, given a specific area of LID, we know that the infiltration rate we will be presented with the infiltration rate for that. And if the number is greater than what the storm event would be, then you recognize that you're going to have a flooding problem in that particular area. So it doesn't necessarily tell you what you need to do, but it will give you an estimate of where you're at in that current planning process. So if you are anticipating that you're going to have to use a stormwater management system, maybe it's in your benefit to design for the best case scenario, right? And know that in one of these particular incidents that you'll have X amount of water. And the reason why that we developed this application is because we recognize that in what we refer to as the limited LID zone, or the extreme urban dense zones, is that green roofs can have a severe impact on stormwater management, whether that's just through slowing it down or through evapotranspiration. And so this is an image taken from one of Daniel's books that has been adapted to look at the system more holistically. But really, we are considering everything, again, like I said, from the roof to its final exit point. So what's the stages that it moves through, and how can we impact that through each level? So the components of the holistic urban stormwater management system is that it's a living system, so it requires maintenance. It's highly technical. It's a landscape engineered system, right? And so it's not just something that you can plant and walk away, but it needs to be looked at as an HVAC system, for instance, right? It requires maintenance. It requires upkeep. There needs to be a professional who understands how it's working in a particular environment, and it can't just be applied and walked away from. And so before designing these systems, you need to look at the soil drainage capacity, whether that's the green roof itself for how quickly it's going to overload, or if it's actually for the LID system and trying to understand the current infiltration rate on that particular site. Understanding the context in the existing stormwater management system, so if you do have something that overloads, we need secondary precautions for this. So it might predict that 100% is plausible, but still recognizing that you have to work within the framework of the city. Locating emergency overflows, executing a watershed analysis. As I said earlier, it's very important to understand the context beyond the site. So what's nice about our application is you can enter in whatever number particular to the area that you're interested in. So if your site's 100 square meters, but you want to take into consideration the surrounding area, you can certainly account for that. Or look at two different scenarios, one where you're taking into consideration just your portion or beyond. Our application is based off of local weather data for the Vancouver climate currently, but the way that we've developed it is we're looking at being able to apply it anywhere. So as long as you can get weather data from a weather station, something that's a credible source, you can plug that in. So even from North Vancouver to the downtown region, if you were to notice two different climates, because of the hills, for instance, you could be able to apply that data in a manner that gives you much more site-specific response in terms of estimates. And then the benefits of improving the microclimate. So green roofs are bringing back pollinators and providing places for birds to rest in urban environments that used to have those spaces that no longer have them. And so designers should take a course, for example, in living roofs, which help severely. So Daniel is a green roof specialist, and he's designed and built green roofs and knows quite a bit about them. But if they're not developed in a particular manner, it's causing negative public impact. So when there's a flaw in the roof, it's something that the public hears about very quickly and prominently, whereas if it functions the way it should, it's often not in the forefront. So we need to be designing these to be quite durable, and we need somebody who's educated to oversee that process from the beginning to the final steps. So designers can do rigorous site and context immersion. This is what needs to happen at the beginning. This is why we would like to reverse the planning process, right? So that landscape architects and these systems are thought about at the forefront, because we need to do these studies to have a great impact at the end. So knowing the site in context, studying the applied research on low impact development, knowing that what the programming is and making potential suggestions to the client. So if you know that it's going to be a concrete structure and they're not intending for a green roof, offer in, right, the fact that a green roof might have great benefits for the site and for the client in terms of HVAC, overloading electrical systems, the evapotranspiration, stormwater management, and then being critical with your own design and setting goals to protect the environment is kind of the goal. So just sort of a quick image is showing, right, how a community can develop for a living roof and bioretention. So in this case, it's looking at more of a rural suburban type concept, but the living roofs can be applied in a manner that they're diverting excess water to public stormwater management systems. So really thinking about the system holistically, right? If the city is going to take on a new community or a new project, how can those systems potentially be tied together so that you're not relying on the stormwater management as your first line of defense? And then some examples of just like a quick section. So thinking about it from the water hitting the roof, making its way to the LID system on the ground, whether that's a bioswale or a rain garden or a detention or retention pond, and then how that can infiltrate and recharge the groundwater, and in many cases deter a lot of toxic runoff into lakes and streams, which are causing issues, as we know, with the salmon population locally. And so some research that Professor Dr. Hans Peter Schreier did was looking at undeveloped impervious and then different levels of impervious, selected LIDs, and then overall all LID options. What we actually found, or what was found in the research, was that you can actually reduce the runoff beyond normal undeveloped land with all of the LIDs implemented. So there's great benefit to these systems. It's just not it's not understand holistically, right, quite yet, with the public and clients and researchers even, how all of them combined can actually have a great effect on urban environments. So there are a lot of benefits of the LID, from reducing stormwater runoff, upgrades. You can reduce the need for upgrading existing stormwater sewage systems, right, by implementing these, which could save the city, for instance, or clients or the developers the need to pay into some of those, right, if the site's undergoing a rezoning. Cleaning the runoff and recharging the water table. So in urban environments, a lot of toxic things are going straight out into the ocean. Providing a continuous ecological habitat. So right now with developing cities, we have parks that are planned and those are great habitats, but they're overrun by people. Whereas if you put a green roof in the downtown core, it provides an amenity for these ecological systems and habitats to grow and thrive, where there's less public interface, bringing back migratory bird routes and pollinators. And then a viewing experience in many cases can have a positive impact on health. So installing them is a planning policy issue. So we developed the application with the intention of hopefully moving it to a city sort of infrastructure so that people are using it at the beginning. But we recognize that there needs to be a lot of cooperation throughout this process. So landscape architects, urban designers, planners, engineers, municipalities, they all have to come together for this to work, right? So if the landscape architect's thinking about it, that's great, but if the architect hasn't designed for it at the beginning of the process, that can mean a lot of budget issues later on. And so coming together at the beginning, looking at it at the conceptual design phase, and trying to push these acceptance and enforcement, right? So the public has to also be on board, which is why we've looked at developing the application so that there's a user-friendly aspect to it and it doesn't seem jarring as if it was a highly structured technical equation, for instance. There are a lot of future goals in stormwater management that we're looking at the Greenskins Lab. So enticing the rain, water and its value, importance and protection. When you see droughts happening, I'm from Oregon, and we don't ever think about droughts in Oregon. We think there's an abundance of water in the Pacific Northwest. And I was just at Wikiup Reservoir, which is at a 55-year low. There's basically just a little stream going through it at this point. So we don't think about it in a context where we see rain for 9 months out of the year. But this is a serious issue that we think needs to be sort of addressed. Creating policies for rainwater on private and public land, stimulating the awareness, initiating long-term LID research. So much of what we are also interested in is if there are green roofs that get developed, that there's a research component to them. Many are developed, designed, built, and then they're left to either degrade or erode. And if we were to have a research component surrounding that, we could begin to understand their benefits in urban environments a lot better. And then developing regulations to reduce water consumption. So we put the irrigation in so that we might harvest rainwater from our roof to actually irrigate that, and it could even go beyond and irrigate the site as well. So we see that as an important, rather than using potable water, right? And then initial cooperation. So really things need to happen at the beginning, and there needs to be good relationships formed there. And then encouraging designers to use visual, oral, and research skills to engage the public. So Daniel and I just returned from Beijing, where we were teaching a workshop on LID and green infrastructure to some undergrads in landscape architecture and planning. And right now China has a large problem where they are concreting over a whole site, and we saw 22 towers, probably between 13 and 26 stories being built on a couple of acres, where they hadn't thought about LID at the beginning, and they were planning on just sending it all into one pond. And what we realized was that the pond needed to be about 6 times bigger to deal with one rain event in their particular region. So they had thought about it, but because they had limited themselves at the beginning, they couldn't account for it towards the end. And then it's not a chore, but it's a celebration. And I think Vancouver recognizes that green infrastructure is really beautiful in a downtown environment. And so thinking about this as a celebration of nature and how we can integrate these systems together. So thank you.